scales and modes form the basis for much of the pitch-centered music that we listen to, including most popular music, most jazz, most folk music, all kinds of music that we perceive as having a tonal center is based on scales and modes. So we'll be examining how scales and modes are constructed, and then maybe learn a few things about making some new ones. We'll start with a basic definition of one of the simplest modes, most common one, the major scale. So if we examine some of its characteristics, we realize that number one, it uses all 7 pitch classes. Only once, none of the letters are repeated, and none of them are left out. The scale repeats in each octave, so it's the same in every single octave. The largest interval that we find is a major second, and there is a clear tonal center. In order for a mode to make sense at all, there has to be a clear tonal center. So we'll start with the major scale. Here's our basic C major scale. So we see all 7 letters are being used. The intervals are these here in the yellow numbers, and so we see that the largest one is number 2, repeated several times, but still the largest one is number 2. And finally, the tonal center, in this case we represent that as being the first one that we write down. That's a general convention, when we write down a mode or a scale, we start with the tonal center and then write the scale out from there. That makes it easy to identify. Now, one thing that happens when we do the modes is that we are able to create some changes, but we preserve some of the basic things of the scale completely. So, for example, the essential nature of doing a mode is to rotate the pitches from, to a different starting point. But we keep exactly the same pitches, we just start in a different place. And because we do that, the interval content is exactly the same as well, except that it's been shifted one way, either to the left or the right, depending on which mode we're doing. When we do this, another way to put this is that we end up with something which has the same key signature. In other words, the accidentals that we're using in whatever the mode is will be the same for all of the different modes. It's just that we're changing the tonal center when we listen to it. So the pitch content is exactly the same for each of the modes. And the interval content is exactly the same. It's just been shifted one way or the other. In this sense, each of the modes of a certain scale are considered to be related. And we use the term related here in the same way that we would use relative in classical music. Relative minor. The relative minor has the same key signature as the relative major. In other words, they have the same pitch content, the same accidentals. Now, when we do change the tonal center, though, the scale takes on a different flavor. It has a kind of a different sound to it. It might sound minor, or it might sound subtly different than the regular major scale. And that is what we take advantage of in composing using the modes. All right, so here's how we do it. We'll take our major scale, here's our intervals, and we simply rotate. In this case, we'll just rotate one position to the left. So the D moves over one to the left, the E moves over one to the left, the F moves over, etc. And so when we do this and then we figure out the intervals, we realize that the intervals have done exactly the same thing. Here is a chart that shows the basic modes of the major scale. The major scale is, of course, the Ionian mode, so that's the one here on the top. Each successive row has been rotated one position to the left. So the first one starts on C, the second one starts on D, the third one starts on E, etc. But you'll notice that the pitches are exactly the same between each of these. Now, in most ways, it's more useful to think of these things in terms of intervals rather than specific pitches. Because if we memorize all the modes in the key of C and then we change the key to B flat, then we have to memorize completely different pitch patterns, even though the interval structure has remained exactly the same. So I think it's more useful to think of things in terms of the intervals. So this is what it looks like with the intervals. And again, you can see that each successive row has been rotated one position to the left, and then the beginning pitch has been moved to the end of the row. All right, so let's try creating a mode from a certain starting pitch. So in this case, we'll create a Phrygian scale starting from G. So we know that this is the pattern of intervals for the Phrygian scale. And so we start on G, then we go up the interval to the next note. In this case, it's going to be up a semitone, so it's either going to be A flat or G sharp. Which one? Well, if you have to use all the letters, then it means that we need to use the A flat. The G sharp, if we use that one, we'll have two different kinds of G, and then some letter will have to be left out. So in this case, we don't want the G sharp, we want A flat. Up a whole step from A flat would be B flat, up a whole step to C, up a whole step to D, up a whole step, half step, to E flat, up a whole to F, and finally up to G. Now if we've done this correctly, then we should end up on the same note that we started with. So you might be thinking, okay, well, if I use the rules that we came up with, are there other possibilities other than the 7 modes of the major scale? And it turns out that there are. So let's look at the rules. So we have to have 7 different intervals. And because the pattern needs to repeat in each octave, that means that the intervals have to add up to an octave, in other words, 12 semitones. And so here's an example of that, the major scale. 2 plus 2 plus 1 plus 2 plus 2 plus 2 plus 1 equals 12. And so that pattern repeats in each octave. Turns out that the only way to accomplish this with 7 different intervals is to use 5 intervals of 2 and 2 intervals of 1. So in order to kind of make a system and figure out, okay, well, what are all the possible combinations? What I did in this chart here was to take the ones and put them in a kind of systematic way and sort of putting them in every possible position that they could be in for the entire chart. So it turns out that this is all of the possibilities. These are all the positions where the ones could be in a scale, a diatonic scale like this. So that means that all the blanks here then will of course become 2s, because all the other intervals are 2s. But we'll get there in a minute. So once we've done this, then the next step is to omit any duplications, because if we duplicate one pattern somewhere, it's really going to be the same scale as the other one, so we may as well just get rid of one of them. So it turns out that if we look at this block of 7 different scales right here at the beginning of this column, that is exactly the same as this column here. Now it's been shifted a little bit. The rows, the last row of the one in the upper left is the same as the first row of the one on the lower right. And then you can see that the rest of them are, line up with these others here. So, but this is, complete duplication. It also turns out that the next 7 are completely duplicated right here. And finally, this section here is duplicated up here. So really, we don't even need the column on the right. We just need the column on the left. And so here it is with the 2s filled in. Um, and you can see that there are 21 unique scales. Down here is our Ionian and Dorian and Phrygian, Lydian, etc. So these are the ones on the bottom are the basic, church modes essentially. And then this one, the next one here, is the melodic minor scale. Now it turns out that the next 7, these here, are all the different modes of the melodic minor scale. So if we took the melodic minor scale and we did the same kind of rotation technique that we did, then we would get these 7. So we'll call those the modes of the melodic minor scale. And then at the top, we run into a little bit of an issue. And these scales here at the very top are a little bit problematic for a couple of reasons. The first one is that you can figure out on your own if you try to write down this scale. So, because remember, we have to use all the different letters. So if we start on C, then the next note has to be D flat, because that's a semitone up. And then the next note has to be up a semitone from that, but it has to be a kind of E. So it would be E double flat, and then we would end up with F flat, G flat, etc. It's like it becomes, I believe the term would be ugly to try to write these scales down. The other thing that's interesting about them is that although the melodic minor modes do have a kind of flavor that's similar to the major modes, these up here have a different quality to them, and the way we perceive them is as whole tone scales with a passing tone. So each semitone, the second semitone we hear as if it were a passing tone in between 2 notes in the whole tone scale. So these aren't really very useful as diatonic modes, but they're interesting. They do sound interesting for sure. Now, what about other possibilities? Here's a famous scale that we all know and love, which is the harmonic minor scale. If we look at the interval pattern here, we realize that there are some differences. So in other words, in this case, we have a 3, an augmented second, and we have 3 ones instead of just 2 ones. It still does use all 7 letters, but in this case, the largest interval is 3. It still has a tonal center, so it does qualify in every meaningful way as a kind of scale or mode. And so we can do the same kind of rotational technique. So here's in the top row here is the harmonic minor scale intervals, and then each successive row has been rotated 1 position to the left. Gives us, 7 scales, each with a slightly different flavor, exactly the same way that we get with the major scale or the melodic minor scale. However, we get a lot more possibilities by having the 1-3 in there. It seems to add a number of possibilities. So we have to change our rule a little bit here. So there still has to be 7 intervals because we need 7 different pitches. In this case, though, the largest interval is 3, and the intervals still have to add up to 12. So it turns out that the only way we can do that with 7 notes and 1-3 is by having 3 intervals of 2, 3 intervals of 1, and then 1 interval of 3. So here's a chart that I made that indicates every possible combination of these intervals. In the case that the augmented second is the starting interval, just because it seemed like a good place to put the 3, you could put it anywhere. Now, what's interesting about this is that each one of these scales, so in other words, this first one, let's say 3, and then 1, 1, 1, and then 2, 2, 2, is going to have 7 rotational modes. So this will have 7, and the second row will have 7, and the third row will have 7, etc. So we end up with 147 possible scales that can be made using those simple rules that we followed. Now this brings up a problem, and that is that we're just getting started here, and we've already got hundreds of scales. We don't have names for most of these scales, and yet we do need to be able to refer to them or to describe what is happening. How do we talk about them? And so this is the method that I recommend using, and that is that you compare whatever the mode is that you're looking at with the major scale that has the same root. So in other words, what we want is to figure out how do we describe this mode here, which has C, D sharp, E, F sharp, G, A, B, C. All right, well, we compare that with a C major scale, and then we talk about the scale through its differences with this scale that we know so well. So the root, in other words, the C, is the same in both, by definition. The second scale degree in the mode we're trying to figure out is raised from the major scale, so we'll call this a sharp 2. The third is the same as the major scale. The fourth is a sharp 4. The fifth, sixth, and seventh degrees in our modal scale are the same as the fifth, sixth, and seventh degrees of the major scale. So therefore, we would describe this mode as being the mode that has a sharp 2 and a sharp 4. Now, assuming that the numbers that we don't mention in our list are the ones that are the same as the ones in the major scale. So the 3, 5, 6, and 7 are the same as the major scale. And that pretty accurately describes exactly what this mode is all about. We could make, you could take any major scale and then sharp the 2, sharp the 4, and then keep all the rest of the notes the same, and then you would end up with this interval pattern and this sound of this mode. So that's the method that we'll be using in our class.